All right. Except I'm not Eldert, but that's okay. So I'm Brian. This is Serverless Messaging Demystified, so hopefully this is the right place for you. So you've had a great conference so far? Awesome. So if this sucks, you still had a great conference, right? Cool. All right, so that's me, and this is me, if it'll work. Maybe. I gotta do this. Maybe. Okay. Well, I'm not sure what I did here to break my clicker. Give me 1 second. Let's try again. It is not going to let me click. That's fantastic. Okay, so we'll do it this way. All right, that's me. I've been a .NET developer for about 20 years, basically since it was first invented. I've been a computer science instructor for Franklin University. I did that for about 13 years. Ironically, though, this is only about my 4th time to Columbus. So thank you for having me. You see a lot of certifications up there. That's not like to brag. The reason I want to do that is let you know if you have any questions about Azure certs, I would love to help you. Ask me your questions and I'll point you in the right direction on how to get there. I also have a couple books, Practical Entity Framework, and a new one coming out next month on the AZ204. Okay, so today we're going to talk about the messaging services at Azure. We're going to talk about event hubs, event grid, service bus, 2 different patterns. If you went to Eldert's talk right before this, you got to see the theory of everything. And in this talk, we're going to do the practical side of things. We're going to talk a lot of numbers because this is what I would train you on if you were taking AZ204 training with me. So there may be a lot of rote facts in here that you're not super interested in, but those are also the things that should help you make a decision when you're going to actually deploy services into Azure. So we're going to start with the big one. Event hub, event grid, what the heck? When do I use what? What are they even for? Do I need one for the other? Yeah, when you first start out, it's very confusing. So event hub is the main service that you want to use if you're going to be streaming data. So what happens is you're talking about big data coming in at millions of records per second from disparate sources, and you want to conglomerate that data. You're going to put it into Azure Storage, or you're going to make a hot path, which will go out and be on some BI dashboard somewhere for someone to make a decision. So ultimately, you're going to create an Event Hub namespace, which actually has a service bus URL, and you're going to choose some stuff about that based on what you want to process. The main things you need to worry about is how much data are you bringing in and how fast do you need to consume it. So basically, you have up to 40 throughput units that you can use, and each throughput unit can have about 1 megabyte or 1,000 events per second. You do pay more per throughput unit, so just keep that in mind. You can also use an auto-inflate, which is essentially a scaling. So we're talking about millions of records coming in. We're going to create this namespace. We're going to choose the pricing tier, and you can see that it's going to cost you a certain amount of money per throughput. You can put those throughputs in place, whether or not you want to have auto-inflate, different things like that. So whenever you create your namespace, if you're going to start writing code against this stuff, if you want to be able to create different consumers and producers that are using the SDKs to push data or pull data out of that stream, you're going to need to have some SaaS or shared access signature keys. And those keys are going to be using that local authentication, so you want to make sure that's enabled. So the different types of producers that you can have within the Event Hub, you can stream either via AMQP protocol, or you can wire it up to your Apache Kafka feed if you've already got that going. There's also an HTTPS option available. So there's different ways to do authentication, and ultimately, if you're going to be streaming a lot of data, you probably want to use the AMQP protocol. The HTTPS protocol requires reestablishing the connection on every event. So you can see what the overhead would be on that. So if you have the AMQP, it's kind of like a WebSocket that you just basically keep streaming that data in. where it gets a little confusing is the data comes into the Event Hub, and you have partitions within the Event Hub. When you create your Event Hub, you have to choose how many partitions you want. If you need to change that later, the only way to do that is to redeploy a new Event Hub. So you need to kind of calculate things ahead of time. Now, partitions, if you've ever worked with Cosmos DB or even partitioning in a SQL table, you're basically trying to group data that's supposed to be similar together. Especially in eventing, you might need sequences on specific things. And so that's what these partitions are for. Unfortunately, the code lets you write directly to a partition by the partition number, but the recommendation is you would never do that. When you send your data with code, you're going to want to use a partition key, which is just a term you make up to group that data together, and let Azure manage which internal partition it goes to. Once you have that in there, you can keep the data for up to 7 days. Unless you want to pay a little more, you can keep it up to 90 days, which means that your Event Hub should never get full. It will eventually expire. On the consumer side, you have a thing called consumer groups. When you create an Event Hub, you're going to get a default group. So as if you don't do anything else, you'll get the default group and you can use that. But if you need multiple reading streams on your Event Hub, you can create up to 20 event consumer groups. And each consumer group can have up to 5 concurrent readers. So what does that mean for you? That means that you're trying to create these different streams, and maybe one group of your applications needs to read the data real time as it comes in, and it's keeping a checkpoint on that data as it goes. But another application is designed to go back and do time aggregate window sliding, analysis over the last 7 days or the last hour. It also has its own checkpoint. And if they were trying to use the same checkpoint, you could get some really big problems. So you put those into different consumer groups, and they're independent of each other. It's an independent read on the feed. So this is just the official picture of all of that. So you have your producers on the left-hand side sending data in. You have your different consumer groups, your different consumers hitting those groups. When you create your Event Hub, if you do the standard tier or better, you can do automatic capture of your events into an Avro format into Azure Storage. So this is a really great way to get cool storage on your big data. You essentially just automatically capture it to Azure. So this is basically what you need to do at Azure to set it up. And because we don't have internet here, I'm trying to show you all the little things that you might run into. But ultimately, the big one is make sure you enable the hierarchical namespace, which is right there. That gives you the ability to set up the data lake and have real data there. You can change your aggregation capture window as well. It's 5 minutes and 300 megabytes by default, whichever one happens first. The shared tokens, we're going to see this a lot today because this is going to be the same as we go into Service Bus. But basically, you have God mode, which is your root key. It can do anything on the namespace. That includes all of your hubs. Or you can create a God mode specifically to a hub. Then you have your producer, which is just sending, and your consumer, which is just listening. You put that into your user secrets, you point your code at it in the SDK, and it just works. So here's a demo, if this will start playing. Here we go. So we're basically going to go ahead and create the different things we need. Here's the shared access God mode for the namespace. And then I'm going to go ahead and have this hub. This is already created. Onside the hub here, we're going to see that there's no shared access spaces, and there's your default consumer group with a chance to make another one if you would like. And then ultimately from there, we have this auto capture enabled. That's where that's turned on. We have the ability to adjust the time window, the size window, different things that are happening there, depending on what you want it to go to. And you can choose your storage account and container that you want it to be captured to. So all of the code that's going to run behind the scenes here is going to go, it's going to be in the repo as well. So you can actually go home and deploy this with the bicep file and plug in your SAS tokens here and you'll be able to create the code and recreate this whole thing. So we're just going to create the SaaS tokens for producer and consumer, and then each one of those will have their own connection string. And then just for fun, we'll make an administrator. This one would be local to the hub. We won't actually use it in the code here, but. So then the code is going to be really small. You can examine the code later, but it's essentially just using the SDK. It's making producers that are sending data, and it's making consumers that are receiving the data, different pieces of the SDK. And it's just going to pull that data, or push the data into Event Hub and then pull it out later. So we're going to run it here just to show kind of what that looks like as it goes into. And I was also showing the Event Hub name as part of the connection string, just to kind of call that out. So here we're going to produce 25 events or something. So this was basically based on a client was streaming all of their application logs into application insights, and they were getting a lot of charges for millions and millions of records. And so the thought was, what if we stream specific application events instead of into application insights into Event Hub, and then just process the ones we care about. So that's kind of what this was based on. So I made some fake events and just stream them in and then ultimately read them. So we grab these access keys, put them in your SDK, and you're good. So this is going to write not only to it's not only going to consume, it's actually going to write a second one into a cool storage path to show we processed it. And again, all the code that's doing this is in the GitHub, so you would just need to pull it down, make your own SaaS tokens on an Event Hub namespace, plug them in, and you'd be golden. So this is just going to read them in, and then at the end of the day, it's going to push those into an Azure Storage account as well, which you could do real processing at that point. That was just a sample. So you can drive in, find the captured stuff here. This is the events. I just download it, show that the message was captured into a text file. And this is the Avro format that's automatically captured when we do the event production. And so this is binary, so it's not rateable by human. And yeah, I'm sorry, it's really small anyway. So essentially there we have Event Hub processing of the data and handling that. And again, the code is available to you later if you want to look at that. So, okay. So I would be remiss if I don't talk about IoT Hub at this point. If you're at all interested in playing around with this stuff, IoT is really fun to work with. It's really quite easy to use, and the same code that works for the Event Hub is going to work for the IoT Hub. It's a subset of the Event Hub. So you could have all that in there. If you're interested in that, there's a couple links for some other things I've done where I've streamed data from a Pi into Azure via the IoT Hub. Okay, so Event Hub, we got big data, we got lots of data being streamed in. You can do some additional stuff behind the scenes to filter that, add in like stream analytics jobs and such, but that's for lots and lots of events. The event grid is what we want to use for a single thing that happened. And we're going to talk after Event Grid about Service Bus, so at this point I want to start by talking about when is an event appropriate or when is a message appropriate. And so there's two things to kind of consider on that. Do I need to know if it was handled? And if I do, that's probably going to be a message. And if I don't care, it's probably going to be just an event. And is there additional information that needs to be part of that thing that happened? For example, we're going to see a sample where we drop a file into storage, and we're going to create an event to respond to that. And all we care about is the URL. And then we'll get the notification, we can use that URL to do more stuff. But if I have some sort of state management or something that was important to keep track of, that's probably better served by a message or something that I can keep track of processing and transactions and different things I need to do. Whereas the event's basically just, let's handle this thing. So everything at Azure creates a monitored event. So if I do basically anything like stop a VM, start a VM, deploy something, delete something, that's all generating events. What matters is, do I want to listen to those things? And when I do, I create an event topic, and then I have subscriptions that respond to that. Subscriptions could be things like an Azure function, a logic app. It could be another webhook. You could send messages to, an event happened, the event payload could go sent to like your Teams or your Slack channel. So all of those different things are possible. So one of the cool things is you can also filter the events. So you can respond to events only if it's a specific type. For example, you can have a blob created event or a blob deleted event, and you can filter down to that specific type. You can also do pub sub, because it is an event. You create the topic, you can have multiple subscriptions to it. And so multiple different consumers can respond to that same event. Again, it's going to be a consumption base, so just turning on the ability to use Event Grid and working with it isn't going to cost you anything until you start sending events and responding to them. You can create custom events, and as application developers, this is a pitfall at times, so something to be a little bit aware of. Again, it's creating custom events is possible and can be done, but a lot of times just remember to evaluate your conditions and say, should I be using messages instead of events in this case? Because do I care more than just about what happened? Okay. So there's retry, there's dead lettering, there's specific things that won't be retried on events. So if you get a 400, a 401, a 403, a 404, or a 413, those won't be retried. Everything else will be retried. So in order to make it work, you have to turn on Event Grid on your subscription. And so once you do that, you can start responding to events. And then within the event here, we're getting on the storage account, we're getting the storage account name and key. We're going to use that for our subscription. We'll create the subscription here, and we're going to make a logic app that's going to respond to it. So I'm going to show you this in a demo, and this is just the pictures of what it looks like trying to set it up yourself. So ultimately, then once it happens, you can drill in and see each subscription. You can then review how many times it's fired and all the different things that happen. So I have a storage account here where I'm going to have an uploads container, and we're going to respond with an event by going directly to the events on the storage account. In order to create it, we need the storage account name and the storage account key, not the connection string. So just make sure you don't accidentally put the connection string in there. So spend a little time highlighting that. I've made that mistake too many times. Okay, so with that in mind, we start creating the event. We can create events here either by hitting the event subscription or using the default. Right here, we're just going to use the default to fire off a logic app. So we'll create the connector for the blob storage. We can name it whatever we want. And so we'll just call this something like upload blob processing. And then we're going to use the access key, but you can see there's other ways you can connect. So once that's done, we'll get a nice little green check mark that says, hey, this is working. And then you just need to get your event grid working. So there's service principal and managed ID, which would be better for a production scenario than a user account. To make this simple, I just logged in as myself and got that working. And then I just deleted all the default stuff here because I didn't need it. And so the main point of this is we're going to drop a file, we're going to trigger it, and we're going to be able to handle that with this logic app. And as I create this logic app, there's a little bug in the portal. I would call that out as well. Ultimately, Yeah, you can enable it, disable it, turn on log analytics, have it integration service environment for it. But what you can see is it says it's successfully created, and you navigate away and it says you're going to lose all your changes. Do it anyway if it says successfully created, because it is. And then you come back and it's there, just like you thought. So you see that it's created the subscription. It has a webhook, and ultimately, if you drill into that, you can see that it's triggering the logic app from that subscription, and this is where all the metrics will be for when it fires. You can put different filters and such there as well to filter it further. So now what we're going to do is just drop a file and see that this triggers the logic app. When that triggers, you see you get this payload. This is an event payload. It's the same for everything, and it's got a data section. In the data section is that blob URL. So again, you're going to get a limited amount of information with an event automatically. This is not doing anything other than saying, hey, this happened. You handle it if you want. And it doesn't know if you did or didn't. It just knows that it fired. Cool. All right, so we talked about Event Hub and Event Grid. Now let's talk about Service Bus. So if you went to Eldert's talk before this, he showed all the really cool patterns. And what I'd like to do is show you how to actually implement those a little bit with some code. So we have the Service Bus. There's two different things within the Service Bus to implement different things. So the first one is the queues, which is going to be for one single message route, and then if you want to have a pub sub scenario, that's going to be service bus topics. So we'll see both of those here in a minute. The service bus queues are going to be available at all the tiers. The service bus topics are standard tier and better. So if you need that, you have to up the payment a little bit to get the topic pub sub. All of the queues are going to be able to guarantee your order, so you can have FIFO processing guaranteed on your queues. The thing that we're really concerned about when it comes to potentially like taking the AZ204 or just making right decisions is, okay, I've got a queue here for service bus. There's also this thing called storage queue. I'll talk about that at the end. Which one do I use? And really, there's just a couple of things to help make that decision. Some of it could be based on the size of your message. Some of it could be based on the volume of the number of messages you're going to need. And some of it could be based on whether or not you want to guarantee order. We'll find out later, storage queue can't guarantee order. Only service bus can. So 256 kilobytes is your message size. You can go a little bit higher than that as well. That has duplicate detection, dead lettering. So the ability to do two different types of modes. So when you're doing service bus messaging or storage queues, you have a choice of, do I want to have a term called at most once or at least once delivery? And so if I need to have a scenario where a message should only be delivered one time, that's an at most once delivery. And the only way to do that is by deleting it as soon as you consume it from the feed. So that's the receive and delete mode. So that's the only way to guarantee an at most once delivery. Storage queue can't do that. And then there's peak lock. Peak lock is at least once. And basically it means I'm going to take it out. I'm going to basically consume that message. But after some time, it could be potentially put back in the queue. Or if I don't manually delete it with my code, it goes back. It'll still be in the queue. So I have a number of slides here again on how to create this. The most important things are going to be like whether you want to have sessions. So again, if you went to Eldert's talk before this, he talked about a couple of different patterns. And one of the patterns was having multiple messages that are grouped together as part of kind of like a, what did he call it, a saga, right? And so having these things together, you could potentially have a session around those messages so you know they're all in order for that specific piece, but you don't have to wait for that piece to complete if you're concerned about another session, so they can run independently but still maintain order. And there's things like, how long do you want to keep the message alive? How long do you want to lock it when you just receive? So that's the actual picture there that's from Microsoft of the sessions where you have your different interests in the messages, maintaining order basing on that session. Again, you have to create the SaaS policies, and let's come back to that. I would like to take a break from the slides for a second and show you some code, if that's all right. And let's pull up Service Bus Queue. While that's pulling up, any questions so far? Okay. Information overload at the end of the day. Oh, this is fun. Okay, so this happened to me before. Give me 1 second, I apologize. When you duplicate your displays, I can see the code. You guys still see it? Cool. All right. Okay, so this is Service Bus Queue. And so in the program here, what we're going to see is we're using information to pull in the queue name from those SaaS tokens. We're going to create the Service Bus client, and then ultimately we're just going to use that to add some messages here. So the code is very simple from what I'm doing here, but we're just going to process a bunch of movies, converting them to serialized JSON, and then throw that into our message via a batch. And it'll basically send those messages here. And so that's how simple it is to push messages into my queue as serialized data. Now the reason that's important is because Service Bus itself doesn't care about what your payload is, but you can serialize it on your own to JSON either side and get that to work the way you want it to. Consumer is going to be very similar, and the only difference is when we pull the consumer, of course, we're going to do some processing. In this program, we are going to do two ways. So I have a process only one message. So this is a very big thing that like you'll find people asking online. Well, how do I get just one message? And so there's a receiver that you can use to do that, or you can pull and have your messages just come in as they're streamed, basically. So as we look down at the polling, you can see it's just going to create an event handler here on the processing of the message. So basically, we're just going to handle the message as they come in live time. And yeah, let's get the one. The interesting thing is the one-time processing only one message. So here was a place that I made a huge mistake the other night when I was trying to record these videos. So this prefetch count matters. So I was pulling one at a time, and I had this prefetch count set to 1, and it was actually consuming 2 messages and only giving me 1, because it was prefetching the second one. So if you use this, be careful that your prefetch count isn't actually removing messages. You can set the mode here. Again, this is the at most once, but if you wanted to change it, you would just do the peak lock, and then later you would have to delete it. Sorry. So that's really hard to see. Okay. So that's basically what's happening there. Let's go ahead and watch the video. So I'm just showing you can create queues or topics here. Again, you have your God mode queue just like you did, or God mode key just like you did in the Event Hub. There's your queues, and then you have different queues you can create, and then also topics over there in the entities, which we'll look at in a second. You set the number of messages so you can max it out, how long you want them to live, locks. If you want to do duplicate detection, it's right here. You can set how long you want to check to see if it's been duplicated. Dead lettering, which means if the message is not going to be handled, you go to a dead letter queue. And that session gives us that first in, first out delivery guarantee, again, and an ability to group them together. So this one's just a default queue. It doesn't have any of that stuff enabled. And by default, it's still going to keep them in order, as you'll see as we do this. We create the same 2 tokens for sender and listener. We're going to replace those in our code and then be able to run that producer and consumer to push and consume the messages. And this is the same code we were just looking at. It's just dropping the keys in now. And again, we just need the queue name and then the specific connection string for what we want to accomplish. And the reason we want to use different connection strings is because we don't want our producers to accidentally consume. We don't want our consumers to accidentally produce. And it's super simple to set up. You can see the name of the keys right there in this connection string. So we push 17 messages into this queue, and then ultimately we'll be able to consume them one at a time or by polling them here using that send listener. So we grab the connection string again, drop that into the listener app, and then just run it, consuming one at a time, or let it poll and get the rest of them out of there. So once again, it's going to have the name of the queue right there as well as the name of the SaaS token. So you can always double check and make sure it's the right connection string. You can see the 17 messengers still waiting for me to handle them, and so we just need to consume them. Sometimes there's a little bit of a delay, so you can see them here as well. And you can see that they're right there in that Service Bus Explorer. You can review the messages, see what things look like. So you got the 2 different receive modes there. If you wanted to actually receive it and delete it at the same time, you could. So this is going to go ahead and consume them. We're going to do a single message. This just proves we pulled the one message out, prove it's consumed from the queue, which is how I discovered my thing was taking 2 out instead of just 1, and then was able to fix that. So again, messages are really great to handle the payload of what your thing is. Like this is your order details or different pieces of information that you need to really actually process, not just something happened, but state of something. Where it gets confusing is you can have events that trigger, messages or events that come from the event hub and have caused the event grid to have an event subscription fire. So just keep that in mind too. Oops. So yeah, that's just consuming all the messages and kind of showing the little bit of a delay here on the metrics, but they ultimately show up. Cool. All right. So let's see if I can trick this thing again. Sweet. All right, so that's Service Bus Queue. Let's talk about PubSub with topics. So again, now you have messages, but maybe these messages need to be handled by multiple consumers. So not only are they need to be handled by multiple consumers, but they need to be handled if the consumer is interested in that message. And we do that by using a PubSub scenario with filtering on those messages. So we can create the topic, and then that topic can have multiple subscriptions, and then your consumers just care about those subscriptions. They also do all the other things that queues do. So you get the ordering, you get dead lettering, you get all the different, different things you could do with the peak mode or the receive and delete mode. So it's just a more advanced queue. It's basically just copies of the queue with potentially different messages based on filters, which is really cool. When you want to do this, you can create filters that cause these subscriptions to only take specific messages. We can do this with different types of the events, or different types of the messages, like different things we're filtering on. But what's going to be most common for most of us is going to be something like a SQL filter, where we care about the subject of the message or something within the payload. And that's what this example is going to do. There's a SQL filter then that we can write that says, if this and or this, send it to this subscription, and then each consumer of that subscription gets an independent copy. And we'll see how that means that the same 17 message gets spread out over some different subscriptions, and the different consumers only see the ones they care about, and they don't affect each other. There's also a correlation filter, which is a little bit more involved, that you can see there's more things you can key on with that. So typically you're going to write similar to what you would see in a SQL query. Is something like some property is equal to this, or something not in this, things like that. So creating a topic is just as simple as creating a queue. You go out there, you create it, you say, what's my max size? How many days do I want times to live? Do I want partitioning? Do I want deduping? Do I want auto-delete? And then this code actually creates the subscriptions and sets the filters. So we do that with our code. So you really only need to run that once, and it sets everything up. And then we have a producer which sends the events, and each event is only sent one time, but then we have the consumer which can key on different subscriptions and then pull only the messages it's interested in. So we have a bunch of movies we're sending. What we'll do is we'll set some filters. They're going to be, I'm going to do this because it's really hard to see that. That doesn't help you. Awesome. Okay, so the code will show this too. We have the MPA rating we're going to key on, and that gives us a chance to kind of look at that. We need the SAS tokens just like before, so this should be pretty familiar at this point. It's like, we've seen this 100 times. And then ultimately, we're going to create that stuff. So let's go back. Let's look at the code real quick so it makes more sense in the video. All right. Any questions so far while I load this one? Yeah. Great. So the question was, is there a recommendation on using a third-party wrapper on top of this, like in-service bus or mass transit? And the answer to that would be, if that works for your company, certainly. Especially if you're using multiple brokers, a mass transit or an in-service bus might give you the ability to like do your work in one place and consume all of them, right? I'm not super familiar with them because I don't use them. More academic in the service bus for Azure, but yeah, it would be a decision that could greatly reduce stress on your developers. Yeah. Any other questions? Okay. Is there any way for me to, okay. All right, so the service bus administrator code is really straightforward. It's just going to make sure that we have a topic that exists, and then it's going to make sure that we have the subscriptions that exist. So we have these things called a rule filter. You see the true filter or the SQL filter. You're just going to use which one makes sense. If you use the true rule filter, it's going to show up like a SQL filter, 1 = 1. So that's what it's going to do. So I'm going to create the topic and 3 subscriptions, one for all movies, one for adult movies. No, not that kind of adult movie. The adult movies here that we're talking about are rated PG-13 or R. So this is, again, that query that just lets me set kind of like a SQL statement that says, how do I filter my messages into these different subscriptions? And so that's all this is. I just refactored this code so that it'll actually, only have to repeat it once. And you can see that as we create the subscription, we're just going to use that rule filter here where we're going to create the rule options. And so the topic name and subscription name and then the rule are passed in to that admin client, and it just creates it for us. So then we would go in and look at our service bus, and we would see all 3 of them there. So then our publisher doesn't care about all of that. All our publisher needs to do is push stuff into the queue just like before. So there's nothing fancy here, but the consumer can care. So based on which subscription I want to listen to, I'm going to pull in those subscription names again, and then I'm going to use those to determine how do I want to consume when I'm building out my consumer. So we're going to create a service bus. So in case you don't know, this is really hard to talk and hear yourself to just a little delay. So like when I trip over my words like service bus, it's because it's a delay thing. So I apologize. But ultimately, what we're doing here is creating this service bus client and receiver. And on the receiver, we're going to use the different receive modes here. So this is again, We're doing service bus mode for receive and delete here. Again, you can change that if you want to. You can even make it configurable. But that's going to make that at most once delivery, so it deletes it right away. And then we'll just receive the messages from the subscription. So they're passing in a choice here. I want to get just the all movies or get just the adult or just the family movies. And the receiver is just going to go ahead and pull those messages based on if it has that message received. So both of it, we're looking at the subscription here, trying to make sure we're pulling the right subscription only. And then that's going to get the messages just from that subscription. So that's basically all it takes is just a simple couple changes to the code, and we're able to do that pub sub just like we would expect. So let's get this back. All right, so you guys should be seeing that. Cool. So this time we're going to create a topic. The topic is going to have information that's going to allow us to do that pub sub. And this is just, there was our queue before. Oh, this is the wrong one. I'm sorry. How about we do this one? So again, we're going to use God mode now on that administrator as well. So we need that God mode subscription key to let us in so that we can go ahead and do stuff, create the topic if we need to, and then create the subscriptions within it. So that's showing they're not there right now. We do have the topic. It's idempotent in the code the way it's written, so it checks if it exists. If it does, it just skips the try to create. So we got to set the SAS key. This is getting old. And then once we do that, we'll run that administrator, and that will create our topics. Topic and subscriptions, excuse me. So I called out the code here too, a little bit, sorry. Wanted to make sure I didn't forget to do that. Is that hard to see up there? Is it? Okay, cool. Down there it is? Yeah, okay. The good news is this is all available to you on the GitHub repo. There's a link to download these slides. The GIFs are in it. I said GIF. Did that make anybody mad? Sorry. There's our subscriptions and topic. We run the client. It creates them at Azure for us via code. You could also have just done it in the bicep or ARM template as well. So you didn't have to write code to do that. I just wanted to show how you can. So there's our subscriptions within Service Bus. You can see right now there's the filter for the sequel rule for the adult movies, just like we had in code. And so it's going to filter those the way we would expect. You could obviously modify it here if you needed to as well. And then there's the all family movies. I'm the king of redundancy today with showing kind of the same thing here, just different filter. And this is the sequel rule filter, 1 = 1. So nothing fancy. Create another set of SAS tokens. I tried to speed this up to like 8 times speed because I knew we would be getting kind of tired of it at this point. So you guys hopefully have seen this enough that you'll never forget this ever in your life. And again, we just pull it in and put it into our code. Obviously, user secrets. Don't put it into your app settings and push it to Azure or to GitHub. You'll be in big trouble. So there we sent 17 movies into the queue, and you can see that it segregates them out by the subscription. So we had 12, 4, and 6, or something like that. You can drill in, see the different amounts there, and we end up having only 16 go into the filters because one of these actually has a not rated, and so it doesn't get filtered out to any of the other ones. It's just in the all movies. But you can see this has only the PG movies in it. And what's really interesting is just to guarantee that when I consume that, it doesn't take them out of the other queues as well, right? And so it's completely a unique stream of those specific messages that were queued for that subscription. So now they're gone, the other ones are still there. So then we'll just consume them all here and improve life. The reason that's interesting is because the end counts on the metrics will show 17 pushed and 39 or something like that consumed. So it's not gonna be a 1-to-1 on your pub sub because we have multiple consumption, which mathematically makes sense, right? So yeah. That's the one thing about a GIF. I can't skip ahead. I did try to speed this up. Here we go. So we can see the counts, and it's very slow at responding too, so you have to kind of wait a few minutes for it to catch up, but there it caught up because I paused the video. You see 4 were consumed, then 29 for the total of 33, which is the different segregations across the different subscriptions all being consumed. All right, so that's Service Bus. That leaves just Storage Queue. Okay, why would I use Storage Queue when I have Service Bus Queue? Well, it's probably going to be cheaper, so that's important. What's interesting when you come back to the numbers is the size of the message is 64 kilobytes, which we saw was a 256 kilobyte into Service Bus. And I've actually upped that now to something like 100 megabytes or something. But they don't recommend you use that much because it's bad. So that was for Service Bus. But you can see that Storage Queue messages are expected to be smaller. But if you ever have a scenario where you're putting a lot of messages in and you're going to go over 80 gigabytes of total message data, you can't do that in Service Bus. You'd have to create a second Service Bus over 80 gigabytes of total data. So if you need that much data, Storage Queue is also going to be something you look at. The other limitations to Storage Queue, again, is it can't guarantee order, and it only has the at least once delivery. It can't do the at most once delivery. So more slides on creating the service queue here. You just go to any storage account and literally go to the queues and type a name and you've got it. The code is going to actually create it as well. And I think I went over the code on this one, so I'm not going to bring up the code. So we could create a queue, but here's the code for it. Ultimately, you can set different lease times. We're going to create the queue client. Just create it if it doesn't exist. It gets a thing called these send receipts, and that's how we can keep track of messages that we're getting sent and reuse them in our code, in this scenario, to update one. You can peek at them and see them ahead of time. You can update a message here. That's what that's doing. And then you can receive, and then you have to do a second step to delete them. So again, we don't have the receive and delete like Service Bus does, where you can get it and it's gone. You have to eventually delete it as well. So that's just going to update a message, and then ultimately there's the delete of the message. And again, all this code is out there for you to review afterwards if you're super interested in that too. So in this one, we just need the connection string from the storage account, and we use the SDK to interact directly with the storage queue. And I'm just going to run it a few times. There's a really interesting thing that happens with queues. So we're going to push them in. We're going to peek at them. We're going to see it takes another minute or so for them to show up. Eventually they show up. You can actually do things with them in the portal if you want. Could be dangerous. You can clear your queue. You can dequeue a specific message, or the first message, sorry. And then you can add additional messages as well. There's a thing that we'll show in a second called leasing. I'll come back to that. For now, we just pulled them, and then we had to do that second step to delete them. So this time, I believe we're going to actually lease them. So what happens is, when I take out a message from storage queue, I can lease it, and if I lease it, nobody else can access that message until either it times out or I basically send it back. And so you see they're not visible when they're leased, and so we wait another minute or so and they start coming back once the lease expires. So it's a way to keep somewhat your messages from getting processed twice, but also guarantee that if it doesn't work for some reason, it goes back into the queue and can be reprocessed. Not super robust, but it is available to you. So again, you can add a message, you can delete messages, you can remove them from the queue, different things there. So. Sweet. Okay. So then ultimately the code goes and just deletes the queue completely, and that's all it's going to do. And that's basically all I have for you today. So we talked about when to use event hubs, event grid, service bus, the different patterns of pub sub versus just a queue, the storage queue, kind of the limitations and drawbacks. You saw a little bit of the code. Again, there's more code out there for you. If you have any questions, I'd love to connect. Twitter, LinkedIn. The code is there. All of this is also in the Discord. I posted it the other day, so if you grab it from the Discord, you'd be able to, basically rewatch any of those videos or grab the code and work with it. Couple of other things real quick. So this is, again, me. Connect with me. If you want to support me, you can listen to my Christian music on Spotify, or you can join my learning room at Microsoft, which is free, where I'm interacting and trying to help people get certified. All the links are in here, so, and then there's the books and stuff too. All right, thanks.